Hello everyone. Now we will see how to conduct experiment on amplitude shift keying, that is ASK. Basically, amplitude shift keying is a digital modulation technique. Here carrier amplitude is shifted between two levels based on the digital message inputs. So this is an amplitude shift keying modulation circuit. Basically here we are using multiplexer IC4052. So in this multiplexer IC, pin number 9 and 10, that means these two pins are the select lines. 9 is a most significant bit and 10 is the least significant bit input. And with these two select lines, we can write 4 different input combinations like 0, 0, 0, 1, 1, 0 and 1, 1. These are the possible inputs that we can apply with these two select lines. Pin number 1, 5, 2 and 4. These are the inputs with pin number 3 output. So there are two identical 4:1 multiplexer inside this IC4052, but we are making use of the first set with 1, 5, 2, 4 input, 3 is the output. So it is a 4:1 multiplexer. But since we are using binary ASK, we have only two possible inputs, that is bit 1 and bit 0. Therefore, we have to convert this IC into 2:1 multiplexer. Therefore, most significant bit input, that is pin number 9 is grounded. So if this pin number 9 is grounded, then MSB bit is always 0. So we can apply 0 and 1 at pin number 10. Therefore, based on that 0 and 1, either we can transmit carrier signal to the output or we can block that signal. So this is the actual circuit diagram. So pin number 9 is always 0. At pin number 10 we can apply 0 or 1. So possible combinations are 0, 0 and 0, 1. When 0, 0 is applied at this point, we get output from pin number 1. So pin number 1 is grounded, therefore output will be 0. When 0, 1 is applied, then we get output from pin number 5. So pin number 5 will be connected to 3, so we get modulated signal, that is carrier will be transferred to the output. So here we get carrier. Therefore, based on this, either carrier is transferred to the output or carrier is blocked. So this is the simple circuit here. And message input, this is separated from signal generator, and we have to set square wave, amplitude 5 volt and frequency is 250 Hz. And when we are applying this square wave, we have to see that offset is applied, DC offset is applied. So we can say that this message input is the input signal with DC offset. Similarly, here we have to set carrier input. Carrier input is 1 kHz signal with 5 volt amplitude, and this part is the clamper circuit. So here both carrier input and message input both are applied with the offset. Here offset is generated because of this clamper circuit. Here from the signal generator itself we are applying the offset. Now we will see the circuit here. So circuit is already soldered here. This is the circuit, and here first we have to set the keying input. Let me make the direct connection to the CRO. Remove this connection. So here signal generator is connected to the CRO. Let me use channel 1. So initially I am keeping it in the AC mode. Let me adjust the amplitude. So this is 2 volt per division. So here 2.5 divisions are covered. So 2.5 into 2. Now amplitude is 5 volt, and set the frequency to 250 Hz. So 250 Hz approximately. So frequency and amplitude both are registered. Now we have to set the DC offset. So ground the signal, align it to the reference line, then keep it in DC. Now we can see that this signal is symmetrical about the time axis. Now we have to shift the level. So use this DC offset knob. Turn the knob, slowly increase the level. Well, now we can see that the negative peak of that square wave is on the time axis, our previous reference line. So peak to peak amplitude is 5 volt now. So now square wave input or message input is set. So here bit 1 is represented by this 5 volt high level and bit 0 is represented by this 0 low level. Now our message is ready. Next we have to connect this signal generator or message input to pin number 10. So it is connected here. This is pin number 10. Next let us set the sine wave, that is carrier. Let me make direct connection from here. So I am using the second signal generator. So again it is connected to channel 1. Ground the signal. Keep it in AC. So now we can see that amplitude is slightly above that 5 volt. Let me adjust that. Reducing the amplitude now. So 2 volt per division for channel 1. Here 2.5 divisions are covered. So 2.5 into 2. So now amplitude is 5 volt. So carrier amplitude is set. Next I have to adjust the frequency to 1 kilohertz. I am reducing the frequency here. It was more than 1 kilohertz. Well, now frequency and amplitude of the carrier waves are set. Now let me connect this carrier wave to the circuit. So I am using this CRO probe now. So it is connected to the capacitor, means carrier is connected to this point. So it is connected to capacitor. So this clamper circuit is used to shift the level of that sine wave. Then it is connected to pin number 5. Okay. This is my reference message input. Now let us see the waveform. So this is the message signal 1010 continuous sequence. So this is the modulator. So as you can see here, for binary 1, that means for this logic high, we have continuous carrier signal, and for 0, for logic high, we have continuous carrier here, and for 0, output is 0. That means this output, it shows the amplitude shift keying output, with logic 1 represented as continuous carrier transmitted to the output, and logic 0 represented as output 0. So this is the ASK concept, amplitude shift keying concept.